Let's go. This is all. I gotta make sure my mic's on today. There's too many people gone. That'd be a bad day. And how can you have a bad day when you're an AP Pre-Calc, right? That's what he's saying. That's what the part Kiwi's saying. All right, so here we go. Let's graph this beast. So, what does a normal natural log? Well, that's not gonna work. That's the Mr. Twilliger markers. What's a normal logarithm look like? Right, and it passes through 1, 0. Is that true for ln as well? Yeah, because ln is a normal log with a base of e, right? So when I graph this, what am I going to do? I have to go left 1, and I also need to, reflect, right? Flip it over. So when I flip this over, instead of pointing like that, it's going to point like down, right? Do you guys see what I did there? I flipped it and shifted it. I flipped it and shifted it. Now, when we're dealing with E, if this is a non-calculator question, are we going to be able to get any of these points? No, right? It's impossible. You can't do it without a calculator. But the big thing they're going to look for is direction and your intercept, right? You need the right x-intercept, you need the right direction. So I'm flipping it and going down. So it's going to look... Wait, and where's my asymptote going to move? Yeah, I still have that asymptote, right? So it looks something like that. Asymptotes help you graph it.
How do we know the asymptote?
Because it's usually at 0, right?
Yeah.
And we moved it left 1.
Oh.
Yep. So can I give my domain? -1 to infinity. We're old pros at this now, right? Like this isn't bad. This isn't too bad, maybe. Oh, we graphed it. I'm sorry. How do I find my asymptote if I didn't know the graph? Remember, you set what's in the parentheses equal to 0. So x equals -1 is my asymptote, right? Does that work every time for logs? Yes, that will work every time. And my asymptote will also give me my domain, right? Or let me kind of know. Now, what's my range of all my logs so far? Yeah, that'll pretty much always be that, right? It'll always be -infinity to +infinity. Do I have an intercept?
Yeah.
I have 2 intercepts. Well, 1 intercept, but it's 2, right? So 0, 0 is both an x and a y, right? I have an x intercept and it's a y intercept. We don't always have y intercepts, right? Because if our asymptote is here, it doesn't cross. You see, this is we're to this section. This is the cumulative, right? We're doing everything for analyzing it. So what's my function behavior? What do I mean by function behavior? You can use limits. That's end behavior. You want to use limits. But I like that. Multiple choice question we just did. Is it increasing or decreasing? This one is decreasing because it's going down. And then what's my concavity of this one? Up. So if it's going up, what's happening to my rate of change?
Goes up.
It's increasing. And I know that's hard to look at, but think about this. Concave up also means it's not going to do that, but just remember that's concave up, and my slope is going up, right? Even though this has a negative slope, it's getting less negative as I go, right? Now we do our limits. And I'm going to do my limit as x approaches infinity. What do they call this? F of x? Hey guys, I get lazy on this a lot, and I forget to write the f of x. This is important, though, when you're answering actual questions, okay? You need to say the limit of what function. You just copy whatever they used, right? because sometimes I get lazy and forget to write that. They won't give you credit because they don't know which function has that limit as it goes to infinity. This, I'm looking at this one. What happens as I go to infinity? Is it going up or down? Going down, so negative infinity. And what else do I have to approach? -1 from which side? The right, from the positive side, and I have to put my f of x, and that's going to go to infinity. Have you guys also ever noticed that your end behavior matches your range? Does that make sense? Like one of them is going to match, one of your end behaviors should always match, like, no, it should, it'll match your range. Because it makes sense, it tells you where you end. Well, for these ones. All right, how do you guys feel about this? If you can do this, you know a lot about logs, actually. You know a lot. This one? What do you mean? Like if you can do this? If you can do this easily, you're probably getting it 4. Like for this section. Because there's nothing really too tricky about this one yet. You know what I mean? So this is a good base one. But if you can answer all that, and don't forget, what did we just do? This is all from Unit 1 as well, right? That was a nice review of Unit 1 without the quadratics and rationals. All right. I just glitched. I glitched in the matrix. All right. Okay, this one's going to be a little bit different now. Let's get a little bit more difficult. Natural log. What's natural log usually look like? Yep. Now, what am I going to do with this 2 to the power? I don't know how to do that. You put out in front, right? Do you remember what we did yesterday? You can't deal with the exponents. So before I do anything, I'm going to put that 2 out in front. Now this is something I can graph, right? That I can sketch a graph. The 2 to the squared I can't. And the other thing I would do if I were you guys is rewrite this as 2 natural log of -x plus 3. Just to remind me that the 3 is positive and the x is negative. Now, why do you think they put that restriction on it? That's the asymptote. And when I square it, it's always going to be positive, right? If it's always positive, I would be able to flip my graph. There'd be 2 graphs, right? By restricting it, it's telling me which side do they want, the left side or the right side. They're going to want the left side because it's less than. So I'm only graphing one of the 2 graphs because this. So if you plug this in your calculator, you would actually see it would look like that, right? Natural log's really easy because you have a button for it. You shouldn't ever have to. I'll show you guys how. Yeah, it's in the math menu. All right. So luckily for us, look what they did. What's our domain of this going to be? Yep. Could I have all said x is less than 3? How do I know that so quick? They told us what to restrict, right? They're not going to tell us something that's wrong. So also because of this, where's my asymptote going to be?
3.
How do I know that? They restricted it for us. Now what if they didn't tell me that, is I would take -x plus 3 and see where it equals 0 if I want to do that way. And I get x equals 3. Or I could have done my transformations. There's so many ways you can do this now, right? We're getting a lot of tools in our toolbox. All right, let's graph it then. So if a normal graph looks like this, what do I have to do with this one? Flip it. So if I flip it, it's going to become like that, right? Now, how far away is my 0 from my asymptote if I'm not doing any funny business? So I can put that right here, right? Or I could think about, it would have been here, but I had to move it to the right. it would have flipped and then moved, right? But honestly, it's probably easier just to remember it's 1 away from my asymptote. And then that gives me everything I need to sketch a graph of it.
Wouldn't it have to be left 3 because of parentheses?
You would go left 3, then flip it.
Negative x plus 3?
You would go, so it would, but you start here and you go left 3, and then you flip it.
Oh, it would be going down.
Yeah, it would be -2, and then when we reflect it, you're at 2.
Okay.
So remember, you translate, then reflect.
I was thinking it would start on the right side.
Say it one more time. I was under a fan.
Like when you're graphing it and it goes out, how much is it? Like it's negative 5. Like that has to stay like that.
Oh, on your calculator? I can show you. You have something wrong with your range of your Y. I can fix that. Yep. It should though. It should. It's restricted somewhere. State the range. Asked, what's my range always going to be most of the time, all the time? Yep. What's my asymptote?
3.
3. Again, I had to do that to graph it anyways, right? What's my intercept? 2, 0. And that is x-intercept. Now this one, am I going up or going down? Going down, so I'm decreasing. My concavity is down. So if it's down, oopsie, down, my rate of change is decreasing. Down, decreasing, up, increasing, right? Like your mood. Down, your rate of change is decreasing. Yes, always left to right. Yep, good question. Always, like a book. You don't have a y, or oh, you do have a y-intercept. Good point, thank you. Our y-intercept, if this is a non-calculator, would be, when we plug in 0, what do we get? What's natural log of 3 minus 0? Natural log of 3, right? If this is a non-calculator, can we figure that out?
Yeah.
No. Oh, yeah. It'd be 9. Natural log of 9. You're right. I'm sorry. So it'd be natural log of 9. You just write it like that. What is, I wonder what that is, decimal-wise. Oh, wait. 2 natural log of 9. Oh, no. You're fine. You could have done 2 natural log of 3 or natural log of 9, right? Do we all agree? Okay. No, they're the same thing. Natural log of 9 equals 2 natural log of 3. I use their key. I would have done natural log of 9. I always plug into original, because if you make a mistake somewhere else, at least you're getting that one right. You know what I mean?
So if you didn't use the y-intercept in there at all,
that'd be wrong, because you do have a y-intercept on this one. Pirate ticket. Limits. What's my limit as x goes to? Now I can't go to infinity, right? I would go to 3 from the positive, and I have to put g of x here. Oh, from the negative. Jimmy Crickets. Math is tough. So from the left, you know how much harder it is to do math and like lecture at the same time? I should just have to do it, and you just watch and you guys figure it out. So when I come from the left, it's going down, so negative. And what's my limit of g of x as x approaches negative infinity? How's infinity? Not bad. That's not a bad lecture, y'all. Peace.